So my name is Dr. Lorna Dugan and I am a lecturer in one of the groups in physics, the Molecular and Nanoscale Physics group. And the group is largely interested in things on the nanoscale, so things that are pretty small. And we need some fancy equipment to look at things on this length scale, and that's one of my particular interests. So something that we're really interested in is life in extreme environments, and we want to learn more about organisms that live and thrive in extreme conditions, extreme for you and me. And these organisms are called extremophiles, extreme loving. And when I talk about extreme, I mean extremes of temperature or environments where you might have acid conditions or high salt conditions. And if we were in those environments, we wouldn't last very long. So we'd like to learn from these organisms that survive and thrive under these conditions. And to do this, we need some tools that we can use to perturb the molecules that come from these organisms. So first of all, the molecules that we're interested in are called proteins, and these are biological molecules, and they're on a nanometer length scale, so perfect for our research group. We want to perturb them. There are a number of different ways that we can do that. We use force because we're interested in how forces of the order of piconewtons can unravel or make these molecules fall apart. So one of the tools that we use is called an atomic force microscope. And this instrument was created in the 80s. It earned its creators the Nobel Prize in Physics in 1986, I believe. And what's special about this instrument is it allows you to pick up nanometer-sized molecules or objects, apply these tiny forces to them, and it allows you to monitor their length extension as a function of time. So using this simple instrument, we can ask interesting questions about the intermolecular forces that hold the molecules together, and we can start to get an idea or build up a picture of what gives the molecules the stability and the ability to survive in the extreme conditions.
My role in the project is the engineering aspect, really. I work on instrument development. I'm currently adapting and building a new piece of kit, a new AFM effectively, to have variable temperature capabilities. This involves a lot of design work. I'm finding the best components for the job. It involves a lot of wiring things up and electronic testing, but I also do a lot of the actual experiments, so working with biological samples and actually characterizing them mechanically in order to unravel their secrets.
Some of these molecules, these protein molecules that we're working with, are enzymes, and enzymes are important because they can catalyze reactions. And these catalysts are already used in industry extensively, but you can imagine there are some industrial processes that need to be carried out at high temperatures or in very extreme conditions. For example, when you have an oil spill, you need to have some kind of chemistry going on to minimize the impact of that oil spill. So extremophile enzymes offer great potential to allow us to exploit their properties for industrial applications.